Okay, so we're going to start by recalling on a blank sheet of paper here all of the identities that I've been pounding into your head over the last few days. All right, I'm going to give you the title of each section, and that'll jog your memory on what type of one to write down. For instance, the Pythagorean. Write that down. The Pythag. You don't have to spell it right. Okay, the Pythagorean section. That is the things that are based on a squared plus b squared equals c squared, or in this case, what? Sine squared plus cosine squared equals 1. So write that one down, that's 1, and then from there you should be able to do the rest of the Pythagorean kind. Okay, remember you can take that starting one, the sine squared plus cosine squared equals 1, and morph it by dividing everything by something, and you'll get the other ones. Okay, anyway, so the next kind that you need besides the Pythagorean, I can't even spell my first word right, P-I-T-H, the Pythagorean kind. The next kind I'm going to do is reciprocal. The reciprocal kind is like sine is 1 over cosecant. It's a reciprocal kind. There are 6 of those. Then there's the cofunctions. The cofunctions are like Batman and Robin, or sine and cosine. And that's things like sine of theta is equal to cosine of 90 minus theta. That's one of them. Oh, you can handle it. Now, normally we don't write 90, we write pi over 2, but it means the same thing. So there's one of the cofunctions. So like sine goes with cosine. Tangent goes with cotangent. I know that feels weird because those are actually evil twins. They're also cofunctions. All right, see if you can write all of those. The next kind I need you to know is the odd even. Those are the kinds where you throw a negative in. And you throw a negative in and either the negative actually sticks, like with sine. Sine theta equals sine theta. If you stick a negative in here on sine, it'll stick and the negative will stay in the answer. On tangent and sine, they're the same. But cosine acts different. All right, see if you can recall all of them from the little, all of them in each of these sections. So somebody who just walked in late, I'm going to remind them what we did. What I'm asking you to do on a blank sheet of paper is to write me out all the Pythagorean ones, all the reciprocal ones, all the cofunction ones that look kind of like this, all the odd even ones that look kind of like that. Okay? Try to recall them all on a blank sheet of paper. We took a little pause there while kids are writing these down. All right, we're back. There's your job and there's my job. One of the things that's your job is between now and next week when we have the test on this, you really need to know all of these. You have to have them all in your head. If you don't have them all, then you won't be able to answer all the questions. There's no hope. Okay, if you've got them all figured out, or can figure them out on the test, not that you have to have this giant list memorized, but that you have to be able to make them. Whenever you make, like, again, I don't sit at home and memorize cosecant theta equals what. I just know I can make cosecant. I just happen to know cosecant goes with secant, so it's secant, and then I know that theta goes with pi over 2 minus theta. So I can make all of these. If you can't make all of them for the test, then you can't answer all the questions. Once you got all of those in your head, the harder part is figuring out when to use what. I'm going to try to give you a better idea today on when you should do substitutions, which kinds work better this way or that way, and so I'm going to give you some more hints. All right, so quick review. I'm just curious to see which ones of you were strong on this, which ones were weak. I hope you all had this one. Sine squared plus cosine squared equals 1. Raise your hand if you had that one on your paper. Good. Not everybody, but almost everybody. Next one. You divide everything by either sine or cosine. Doesn't matter. If I divide everything by sine, I'd have 1 plus cosine divided by sine is cotangent equals 1 divided by sine is cosecant. Who had that one on their paper? Okay, good. Next one. Go back to the original. Divide everything by cosine. And sine over cosine makes tangent plus 1 equals 1 over cosine, which is secant. Who had that one written on their paper? All right, good. Make sure you understand, yes, this one tells me secant is this. So wherever I see secant, I can put that. But it also tells me tangent, doesn't it? You just subtract 1 from both sides, and you know tangent then is secant minus 1. See, I can get rid of that, and the tangent would be secant squared minus 1. All right, so, yes, it's supposed to be squared. I'm sorry, I should put a little squared there. I put a degree instead of a squared. Okay, long day. So now the reciprocal ones, those were things like sine equals 1 over cosecant. I really don't even want to go through all of them because there's 6 of them and it takes a while, and I think you know all the ones that are evil twins of each other. Just don't forget that you can start with the ones that are the evil twin, like secant, and go back to the normal one, 1 over cosine. Okay, those should be easy. The cofunction ones, you can start with sine of theta equals cosine of pi over 2 minus theta, or you can start with them this way, like sine of pi over 2 minus theta would be cosine of what? Theta. Okay. Now those, again, once you start, it's really pretty easy. As long as you know that sine goes with cosine, and tangent, this is a little weird for some people, goes with cotangent. It is, the only difference is the word co, right, between tangent and cotangent. So those are cofunctions. Even though they're also evil twins, they're cofunctions. Then I could go like this, and then this. Cosecant and secant are also together, yes. All right, back to recording. We have odd even ones. The main thing is to keep straight which ones the negative will stick and which ones the negative doesn't matter. And the cosine is the one where the negative in here won't change the answer. It's still just plain cosine theta. All right? So sine and tangent both do matter. The negative will stick. What does this mean? This means if you ever see negative or tangent of negative theta, for instance, you can replace it with this. It doesn't look that different, but sometimes it helps. This one's especially key because you might have this negative in the problem, and what if you want to get rid of it? You can replace this with that. They're equal to each other. The negative in there doesn't matter, so you can replace it with plain old cosine of theta. All right. Now, there's your big list of all of these all these identities that can help you when you're doing problems. So what should you do when you hit, like a problem like, for instance, let's do this one. Number 3 on the worksheet 2, part 2 it's called. Tangent theta minus cotangent theta equals 0. Okay, how do we use these identities? Well, first of all, do you see anything squared in there? No. So therefore, I can rule out the Pythagorean ones. Okay, next thing. Am I multiplying those two guys together? If I was, I'd be thinking maybe reciprocals. Like put in 1 over cotangent, because then if it would be tangent times 1 over tangent, that'd be awesome. It would cancel, but this is not a multiply problem. So it's probably not a reciprocals type of thing. All right, but here is the general rule when you're trying to get equations like this, and I haven't stressed this enough, so I want to make a big point of this. You want to get this down. To be able to finish in a problem like this, it needs to have only one function in it. If you are left with like cosine and sine in a problem, you're not going to be able to give me the answer as a degree. You could if you used graphing, but we're not going to be using graphing. Okay, so you have to, all the problems that I give you today, they will always come down to simplifying down to only one function in them. If you can get the problem down so it's only got tangent left in it, then you can answer it. Or if you can get it down so it's only got cosine left in it, then you can get an answer. Let me show you what I mean. Let's say I got down to this. 3 cosine of some angle was equal to 1. If I'm down to just cosine left, I can get the cosine alone then. So I divide by 3 on both sides. And I'd have cosine of some angle is equal to 1/3. Can you use a calculator? Yes. So if you were going to use a calculator right now, how would you figure out this answer? With inverse trig. So you'd type in what? Inverse cosine, and then what? 1/3. So grab your calculator right now. If you don't have one, borrow one from me. Hurry up. We're going to go cosine -1 of 1/3. And it'll tell me what the answer is. Now, if you have your answer in radians, or your calculator in radians, it'll tell you radians. If you have your calculator in degrees, I think that's a little easier. You can use degrees. Either one does work. But what I'm going to show you is the degrees kind of way to do it. So did you get an answer in degrees, anybody? 70 point what? 0.5? Let's call it 70.5. Okay. All right. So 70.5, if I was rounding, wouldn't that round to 71? Okay, so I'm going to round this to a whole degree. Say 71 degrees. Now, why is that right and yet wrong? It's not the radians thing. I said degrees are fine. Yes, sir. Because there's 2 answers. That's right. Okay. So if the answer for this is 71 degrees, you got to always remember there's 2 answers for all of these things. And if there's certain circumstances, there's actually 4 answers. But in this case, there's 2 angles this would work for this. Can you picture what 71 looks like? Would you agree it's something sort of like that? And this is 71 degrees? All right. So then all students take calc. Where else is cosine positive? It's positive here. And where else is cosine positive? Down here. So there must be another triangle down here where it's 71. So it seems like you should just be able to say -71. But the answers that we want are only positive answers. So how can I say -71 in a positive way? Take 360 minus the 71, and I'll be back to 299. Is that right? I think it's 299, isn't it? 289. Thank you. So then there's 2 answers to my problem. 71 and 289. Do you get that? You focused on this? All right. So we'll do a memory wipe and it'll be all fine again. Okay. All right. So I guess I need you to get this before I can go on to doing problems like number 3 that I wrote on the board here. So I need to do one more like this first to make sure you're with me. Let's say I had 6 sine of theta is equal to -3. Would you solve that quick? 6 sine of theta equals -3. Is it down to just one function? Yes, it is. So you can solve it. And yes, you can use the calculator to help you. So what do we do first? Good. Then it's sine theta. Sine theta equals -1/2. In which quadrants is that true? Sine has to be negative down here and down here. So there's some angle, my calculator will tell me, 30. But it's really 30 down this way, so is it really 30? No. It's 360 minus the 30, which would be 330. Isn't there another answer? Yep, because we just did this one. Now we're going to do the one in this quadrant. So then that would be a triangle that looks like this. I'll do it in black. This is 30. So now I take 180 plus the 30. What's that? 210. You see how the two answers came about? Raise your hand if you got those answers. You get that. Okay, good. Now, if we have one like the one I started with there, probably a little too aggressive to start with, yeah, then I need to get it down so that it only has one function in it. Can you think of anything I could do so that it would only say one function? Switch cotangent to what? To 1 over tangent. Now I said before that's not going to make them cancel, and that's normally the time you do it, but this is another time you would do it, is because now I've only got tangent in my equation. Now here's the thing that you've got to be able to think like these are just letters. If I had said x minus 1 over x equals 0, what do you think I want you to do? Do a common denominator thing. Or, here's another way instead of a common denominator. Would you agree to get rid of the fraction part here? Would you agree that I can multiply everything by x? Watch what happens when I multiply everything by x. What's x times x? X squared. Minus what's x over x? 1 is equal to what's x times 0? 0. Does this look at all like one of those problems where you'd factor it like this? You'd say x and x plus 1 and minus 1, and I'd have my two answers that way? It should look like that. All right, so I just gave you the little helper thing for doing this problem, except it was all in algebra. Now we got to do it in trig. So multiply everything by tangent. It's all multiplied by tangent. And what do I have now? Tangent squared minus, that's 1, equals, what's that? That's 0. Now there are two ways to do this part. I can either do that factoring thing I just showed you. That'll work. Or there is what I think is maybe a little faster way. Add 1 to both sides. And then what do you think I'm going to do? Square root. And don't forget when I do the square root that I want plus or minus. So it's tangent of theta equals plus or minus, what's the square root of 1? 1. And now that breaks up. I think the best way to do this is to remember it's actually two parts. Tangent theta equals 1 and tangent theta equals negative 1. And I do this side, and you're asking yourself what degree would give me a tangent equals a 1? Or I could say tangent negative 1 on my calculator of 1. It'll tell me the degrees. And I think it's 45, isn't it? Okay. And then this over here, same thing, except once I know that it's 45, it's really all about 45s, but they're in different places. I would have all kinds of little pictures on my paper when I was doing these. I'd say, okay, where is tangent positive? All students take calc. Tangent's going to be positive here and here. And so if it's 45, my calculator tells me it's 45. So then it's 45. But what's the other one that's over here in 45? 135. Oh, wait a minute. You're right. I just did that wrong. That's going to be an answer, but it's going to be an answer on the other side. I'm sorry. We needed it down here, right? So sorry. This is supposed to be 45 down there. So you take 180 plus the 45, 225. We'll use that other number in a second because we needed one here and here for this part. For this part, where's tangent negative? It's negative here and here. So here's this one, which would be 135. And there's this one, which is 360 minus the 45. See how there's 4 answers to that? Okay, you didn't waste your time if you did that. You just, now you have done one of your homework problems. All right. Now these are challenging, and I want to do another one with you, but then what I've decided to do is record a separate video tonight after school, and I'm going to, I figured out that just the answers alone to these is not enough. Like, you can look at the answer and say, okay, it's supposed to be 30, but I have no idea how to get there. So what I'm going to do is record a video answer key for this so that you can see how to do them. Okay? So this is a special occasion because this stuff is the toughest stuff we have. Watch that. It'll help you understand how to get these done. I'm not going to do it for you right now. And I strongly recommend that you try them on your own, because if all you do is watch me recording how to do all of them, you won't get a chance to practice and stretch your skills at all. All you're going to do is hear me, oh, he's smart enough to see that it can factor or whatever. You have to learn how to do this yourself. All right, so let's do one more. Let's see. Let's use one that looks kind of like we can use the what do you call those? The identities for. Like number 4. It looks like this. Sine squared theta equals cosine squared theta. Whenever you see those little squareds in there, little bells should be going off in your head like, ooh, that looks like Pythagorean. And so what's that general form? Sine squared plus cosine squared equals 1. Been nice if they would have just added them together for me, because then I could just replace it with a 1. But they didn't. But that means I could replace sine with what? 1 minus cosine. So I go 1 minus cosine squared theta equals cosine squared theta. You know what I just did there? Just replace the left side with 1 minus cosine. Do you see that that gets me one function? Remember how I said you had to get it down to one function before you could really get an answer? So now it's down to just one function. Okay. So now if I can just get this cosine completely alone. So I got cosines on both sides. It's sort of like having x's on both sides. Yes, we add cosine to both sides. And then I have 1 equals cosine plus cosine. What the heck is that? 2 cosine. And now I can get the 2 off of there. Divide by 2, divide by 2. Cosine squared is equal to 1/2. I'm so close. How do you get rid of a squared? Square root. So I take the square root of this side, square root of that side. What the heck? What's the square root of 1/2? So then, if you have, yep, we're almost to that part. Cosine, it's not squared anymore, of theta, it's got to be equal to some weird square root, and it's plus or minus. Plus or minus the square root of 1/2. Could your calculator maybe come in handy in doing this? Yeah, you can use your calculator. So then, if you want to use inverse trig, you do inverse cosine of square root of 1/2, and because it's plus and minus, inverse cosine of positive 1/2. Square root of 1/2. I mean. Oh, wait a minute, right there. Ooh, you came up with something pretty good there. Aren't they going to be the same? This is inverse cosine. The inverse cosine have all the same rules as regular cosine? I know what you're thinking. You're thinking of this thing, where you go like this. And if you stick the negative in here, that it comes out to be positive cosine, right? But that's not an inverse cosine, so it might not work out as good as you think. But we'll try it. Try it. Just take a calculator and try it. What'd you get? On the left side? Would you do the left or the right side? Did you do the one that was negative or positive in here? Okay, on this side then. What'd you get? 135? Sounds right. Okay. How did you get that? Calculator. Typed it in, right? Did you use the square root? You can't put the negative under the root. That would be a problem. It doesn't like that. All right. Okay. And has anybody tried this one? And that's 45. Interesting. Aha. So if you're doing the one where it comes out positive, okay, this one's the one where it's positive, then that's got two answers. Remember? All students take calc. And if they're based on 45, the two that are positive are these two. Wait, cosine isn't positive there. Sorry. Those two. So it's 45. And then you know there's another one down here. And that's not 45. It is 300 and something, right? 315. So if it were me, I'd always draw out this at the end and make sure, because almost every problem has two answers and some have four. Okay? So you just don't even think about leaving an answer that's just one thing unless you're positive you've already ruled out that the other one doesn't work or something. All right, so, and then this one over here, these were the ones where it was negative. Where is cosine negative? Oh, students, take calc. Cosine is negative here and here. So then this has to be, well, it already said it was 135. So then that means this must have been 45 right here, right? So that could be 135. And then what would this one be? This one would have to be 45 also, so then the whole grand total all the way around to here would be 180 plus 45. Okay? Now, think of it this way. Wouldn't it be sad if this class didn't have like one really challenging test? I mean, wouldn't you want your class to have one hard test? Okay, some of you wouldn't want the hard test, but many of you have gotten A's without even trying that hard all year. No, it's not going to be put to a vote. So there will be, no, even with 10 votes, I wouldn't have a chance.
Okay, we'll give you one less thing per class.
Still lose. Okay, and then if one kid voted with me, you'd all duct tape them to their locker or something. So, all right, anyway. So moral of the story, get these down so that they're only one function. If you do get it down to one function, watch out, there's probably two answers, maybe four. If you ever do square roots, make it plus or minus on the answer. Last thing I want you to watch out for is quadratics. You should be noticing if you ever see something like this, it's down to one function, isn't it? It's only sine, right? But yet you'd still have a hard time solving it unless you notice it's a quadratic. So whenever you get something like this and it turns out to a quadratic, if I were you, I'd replace it with x squared plus x plus 5 equals 0. And it probably will just factor nice, and you can get your answer. In this case, I don't think it would factor nice, would it? No. 5, we could do 5 with 5 times 1, so that if this had been a 6, it would have factored nice. So let's just throw in and make that a 6. I'll cheat a little bit. Okay, then, if this had been the problem, I'd have x plus 1, x plus 5. I'd have two answers, x equals negative 1, and x equals negative 5. That's when I'd go back. Don't talk now. That's when I would go back and resubstitute in and say, I was cheating by making this sign into an x. It's fine as long as at the end I make it back into a sign. Get what I'm saying? And now I'd solve this, and then I'd solve that, which by the way is impossible, right? Because sine can never be negative 5, so that one I'd just throw out, and I'd have probably two answers for that. And my calculator could probably tell me what they were with inverse trig. All right. So there's some things to watch out for. Also watch for a video I'm going to put up this weekend about how to solve some of the tougher ones on here, like a step-by-step kind of thing. I'm not going to put all the answers up because I think some of the teachers would be angry with me if I just gave you all the answers, like how to do all of them. But I'm going to at least give you a bunch more of the ones from the worksheet. Okay, so watch for that video. Yes? Okay, question is, if on the test, would it be smart to take a piece of paper and just write out all the identities first? Not really, because you'd be writing down a bunch that you don't need. But let's say that you see a problem that has this in it. Sine of pi over 2 minus theta. It's in the middle of something else, it's over cosine theta or something like that. But you're like, oh, that's one of those kind that has the cofunctions. Would it be smart then, on a separate sheet of paper, write out a few of them that might be helpful? Yeah. See what I mean? Let's say that you get to another problem. It's got a sine squared of theta plus cosine squared of theta. That reminds you of the Pythagorean ones, and you maybe write down the one that's got those in it. Or, maybe it was secant squared theta is equal to 1 minus blah, 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 blah. And you're like, oh, that's one of those squared ones. Then you should take the time to go write them out. So only write out the ones you need, but you should be able to write all of them out if necessary. It would just take too much time to take, 10 minutes to write them all out. Yep. You could. You really could. If that feels more comfortable to you, and you want to start with a blank sheet of paper during the test, and you write out all of all the identities, go ahead. You can do that. It would probably only take you 5 minutes. All right. So what you're doing for the rest of the hour is working on the other worksheet, and there is a book assignment. It's right here, page 452. 51 through 62, that's 11 questions, 12, 13, 14 problems out of the book. You're not due till Monday, all right? So some problems from the book and your worksheet that I gave you yesterday, all due Monday.